We're going to mix the exponential operator with some divisions now. Now, if you can remember from Bedmas, right, that multiplication and division are essentially the same operator. They happen at the same time in your order of operations, and one just undoes the other. So when you apply exponents to multiplications, you apply them to divisions in exactly the same way. So for example, this one here, this says 3x divided by 2y, but it's multiplied by itself 4 times. So that's going to look like this. And if you can see from that, you have the number 3 multiplying once, twice, 3, 4 times. You have the x multiplying itself 4 times. You have a divide by 2, divide by 2, divide by 2, divide by 2. That means you're dividing by 2 4 times. And you're dividing by y 4 times. So net, everything that was in this bracket with the exponent 4 on it has the exponent 4 attached to it. 3 to the power 4 is 81. And 2 to the power 4 is 16. And when you're doing a division one, unlike the multiplication ones where you're able to take two x's and put them together, in a division one, you're looking to see if anything divides out. So if I look at this form, I have 3's on top, 2's on bottom. Those don't divide each other evenly. I have x's and y's on top of each other. They don't divide evenly. So this is as reduced as it can be. Even if the expression's more complicated, it's just got more stuff in there, more letters, the exponent law still applies. Everything that was in here gets that too. So I'm going to have to do 2 squared. I'm going to skip a couple steps here. X cubed squared, that would be x cubed times x cubed. That's 6 x's in a row. Y gets the squared. I'm going to need 5 squared. And z to the power 4 squared would be z to the power 4 times z to the power 4, which would be 8 z's all in a row. So there we go. Again, check the top and the bottom for anything that divides out. 2's and 5's do not divide evenly into each other. X's, Z's, and Y's are all different letters, so nothing here simplifies. So I can just square that 2 to get 4, x6, y squared over 25, z to the 8th. So in this one, the division is outside of the bracket with the exponents. That's telling you that this division is not affected by the cube, nor is it affected by the squared. It's only the stuff in the numerator that gets cubed, and only the stuff in the denominator that gets squared. So if I apply that, 2 cubed x cubed over x squared and y squared. Okay. Unlike the last two examples, I have something on top and something on bottom that match. That means that some of these are going to divide away some of those. To show you how to do that, I'm going to write them all out. So I've got a 2 cubed and 3 powers of x up here, right? X times x times x is x cubed. And I have a y squared down here and 2 powers of x there. So when you have x on top and on bottom, I mean, that's saying take 2 cubed, multiply it by x, divide it by x. Well, if you multiply by something and then divide by it right away, you just undid it. Multiply by x again, then divide by x again. This x doesn't have anything to balance it in the bottom, so it gets to kick around. This y squared doesn't have anything on top to balance it out, so it sticks around. There's no numbers to count to divide out the 2 cubed, so it sticks around. So I'm going to be left with this 2 cubed, the y squared, and a single x. So that will reduce as 2 cubed is 8. This is gone, this is gone. There's an x up here. This is gone, this is gone. There's a y squared in the bottom. So if the division is outside, these exponents are only applied to the numerator or the denominator separately, and then you may end up with terms that divide each other out. So I have a complicated example here with stuff inside an exponent, stuff inside an exponent, but the division is not inside those exponents. So I'm only applying to the numerator and I'm only applying to the denominator. So cubing all this stuff, 6 cubed, x squared cubed, that would be 2 and 2 and 2, which is 6. The y cubed. I have a 4 squared. I have an x squared. And I have a y cubed squared. So 3 of them, and then 3 of them would be 6 of them in total. All right, I have a mess of things to clean up here now. First off, I notice that both of these numbers are, well, actually skip that. We'll come back to that. 6 cubed is 216. 4 squared is 16. Now, if I wrote this out the long way, I would have 6 x's on top, and I would have 2 x's on bottom. And if you go through and start eliminating those, 1, 1, 1, and 1, that leaves me only 4 x's in the top of this fraction. So the x to the 4 goes up here. If I look at the y's, I have 3 y's on top, and I have 6 y's on bottom. So one of these divides one of those, one of these divides one of those, one of these divides one of those, and I'm left with 3 of them, but they're in the denominator. So in they go. Just keep them down here. So looking at that, you've simplified the x's and the y's, and looking at the numbers, I see that they're both even. They both divide by 2 at least. I'm going to try cutting them in half. Half of this would be 108. Half of this would be 8. Now those cut in half again, that would be 54. That's 4. Now those cut in half again, 27. Half of that is 2. This number doesn't divide evenly by 2. It's not an even number. 27 divides by 3, divides by 9. It doesn't divide by this, so this fraction is as reduced as it can get. 27x to the 4 over 2y cubed. So the thing I was saying at the beginning, if you can look at those numbers and you can break them into prime factors. So 6 happens to be 2 times 3. So 6 cubed would be 2 cubed times 3 cubed. So I'm going to do that up here. Four happens to be 2 times 2. So 4 squared happens to be 2 times 2 squared. My face is getting in the way now. If I apply that cube to this bracket here, I ended up with a 2 cubed, a 3 cubed, and an x to the 6 eliminates an x to the square. So right, 6 minus 2 of them would be 4 of them. 2 squared, 2 squared. A y6 in the bottom cancels out 3 of them in the top, leaving y cubed. Now, if you look what's going on here, I've got 3 powers of 2 up top, and 2 squared times 2 squared is 2 to the 4. Well, this here has 2 times 2 times 2 on the top, and 2 times 2 times 2 times 2 on the bottom. This divides out this divides out this divides out this, and I'm left with just one factor of 2 in the bottom. So I can eliminate this thing and that thing, and it leaves just the 3 cubed x4 over 2 y cubed. Because this and this have canned each other in. Now, if you notice that 3 cubed happens to be 27, then you get an identical match to what we had over there. So if you're going to do it this way, you have to be able to spot numbers that will reduce fractions. If you're going to do it this way, you have to be able to break numbers into their prime factors and distribute the exponents in order to eliminate extraneous values. Okay, I am going to do that thing where I split the coefficients into their prime factors. We're just going to do that from the start so that it doesn't end up quite so confusing. So number 30. 30 is 2 times 15. So if we see an even number, just cut it in half. 15 is not even, so it doesn't divide by 2 again, but it does divide by 3. That would be 2 times 3 times 5. Now 3 doesn't divide evenly by anything other than 3, and 5 doesn't divide evenly by anything other than 5. So these are the 3 prime numbers that make up number 30. So instead of 30, I'm going to write 2 times 3 times 5. And then I have a y squared, a z, and an x to the 4. On the bottom, I have the number 18. So start with 18, cut it in half. That would be 2 times 9. Well, 9 doesn't divide by 2 again, so I try 3. It does. 9 is 3 times 3. So instead of writing the number 18, I can write 2 times 3 times 3. And I have a z cubed and an x squared. All right, so if I go through here, and I apply the exponent law, the division is outside the exponent, so this 2 only affects the numerator, this 4 only affects the denominator. And now I'm going to apply the exponent rules. I have a 2 squared, a 3 squared, a 5 squared, y squared squared, that would be 2 and 2 gives me y to the 4, z squared, And then x4 squared, that would be 4 and 4 is 8 x's. I have a 2 to the power 4. I have a 3 times 3, that's a 3 squared. And a 3 squared to the power 4 would be 2 and 2 and 2 and 2 is 3 to the 8. Z cubed to the 4, 3 and 3 and 3 is 12. And then x squared to the power 4, 2 and 2 and 2 and 2 would be 8. Okay, so if we go along and we look at all of our powers here, just going to put a line in. I have 2 powers of 2 in the numerator and 4 powers of 2 in the denominator. That means that these are going to be eliminated, leaving only 2 of them down below. I'm going to put that in. If I look at the 3's, I have 2 powers of 3 in the top and 8 powers of 3 in the bottom. That means that these 2 are going to be eliminated by these, and 6 will be left down there. The powers of 5, there's nothing underneath to balance them, so they will make it into the new fraction. Powers of y, nothing to balance them, so they will also make it into the new fraction. I have a z squared on top and a z12 on the bottom. So these 2 are going to cancel 2 of those, leaving 10 behind. And I have x to the power of 8 up here and 8 powers of x down here. Those are completely balancing each other, so they are going to completely eliminate each other. So they're gone from my finished problem. So my reduced fraction then is 5 squared y to the 4 over 2 squared 3 to the 6 z to the 10. So if I were to finish that off, 5 squared is 25. 2 squared is 4, and 3 to the 6. Oh, it's 81 times 9, 729. I'm going to fact check myself on that. 3 to the power 6. Yep, perfect. And 4 times that would be 2,880. Oh, I think that's going to pop up to 292. Let's just use the calculator. 2916. Z to the 10 was 25 y to the 4 on top. All right, now because I did all this, I prime factored it and I canceled out all the extra numbers. I know that this is in its smallest form, that this is not going to divide by 25. So I don't have to worry about reducing the fractions. That's helpful when you get into more complicated problems. If you can eliminate stuff based on your exponent laws of the division or whatever, it helps to keep your final expressions a little tidier. Like I can see all the bits in this line that make up the answer to this expression. Okay, so good luck, I guess. Off to the practice problems.